Hi again. To schedule the bottleneck, and we did talk about the bottleneck. The bottleneck is the facility or function that uh, restrict us from achieving more. So, for example, if we look into this diagram that we have a work center A, B, and C, and we see that work center B is 50 hours. That's the output of it. So that work center will hold us back, and we're not going to progress with this. We're going to basically be restricted to the output of B, and that would be the flow of the process. It's just basically we cannot produce more than 50 units per hour. So the bottlenecks, it's the process that hold you back and prevent you from achieving more output. And one of the things that we consider to measure the output of a process is called the throughput. The throughput, basically the total volume of products passing through the facility. And the bottlenecks control that throughput. So work centers feeding bottlenecks will build inventory. So imagine that somebody feeding at a faster pace, they will pile inventories ahead of the bottleneck. And work center fed by the bottlenecks, they have their throughput is controlled by the bottleneck. So the bottleneck is an issue in operations. We did talk about it in previous chapters, but these are an issue that we should solve it. Now, here's an example of a bottleneck. We have a wagon wheel assembly of 1,200 sets, 2 per week. We have a handle assembly of 450, final assembly 550 wagon per week. What is the capacity of this? These are some questions that I want you to answer it. And what is the capacity of the facility? What limits the throughput of the facility, and how many wheels assembly should be made? What is the utilization of the wheel assembly, and what happens if the utilization is 100%? So here is the wheel. Here's the wagon that we're going to make. As you see, there are 3 components. The first one, and the first answer for what is the capacity for this factory? If you look into this here, you will see the maximum capacity would be 450, because the handle assembly is the bottleneck, and that will prevent you from doing more. So you cannot produce more than 450 wagon per week. Now, the second one would be, the second question would be, what limits the throughput of a factory? Is the handle assembly. How many wheels assembly should be made? All right, now how many wheels assembly should be made? So let's take a look into the assembly that we have to make is basically 400. Since we can make a 450 wagon, and each wagon would need 2 of these, so that would be 450 times 2, that would give you 900. So the 900 would be the answer for C. Now for the utilization of wheels, so now we could maximum utilization of wheel assembly of 900, but also we could do 120, 1,012 and 200. So 900 divided by 1,200, that would give you 75 utilization. And then what the last question, what happened if utilization is 100? If we have utilization of 100, we will have excess inventory of wheels assembly. So we're not going to use them. Basically, we will build up inventory because of the bottleneck of 450 wagon per week. So there are 7 principles for the bottlenecks. These are the utilization of a non-bottleneck resource. Is the bottleneck resource is not determined by its potential, but by another constraint in the system. Again, the utilization of a non-bottleneck here, we're talking about non-bottleneck operation. It is utilized or determined by another operation, which is most likely going to be a bottleneck. Utilization of a non-bottleneck is 100% of the time, does not produce 100% of utilization. Again, this is just because of the bottleneck that you have, and you're not going to produce 100% utilization. Number 3, the capacity of the system depends on the capacity of the bottleneck. Principle number 4, time saved at a non-bottleneck saves the system nothing. So it doesn't matter if you save anything. The most important thing is the bottleneck operation. So we have to save the time at the bottleneck. Capacity and priority must be considered together. That's a principle. Number 5, we need to consider the capacity and priority when we do the bottleneck operation. Number 6, loads can be and should be split. So sometimes we do the split load. We could assign we could buy another machine actually to process. In this way, you could split the load, one for this machine and another one for the other machine, and this will help you to relieve the bottleneck. Focus should be on balancing the flow. So we have to balance the flow of the shop. We don't want to pile so much inventory before the bottlenecks, and we don't want the other the process that fit by the bottleneck to be starving because of the bottleneck. All right, so how we could manage this? There's a way to manage the bottleneck, which is establish the time buffer before each bottleneck. So this is where you need to build a buffer so you prevent that bottleneck from starving. Control the rate of material feeding the bottleneck. Do everything to provide the bottleneck with a capacity, so do not let the starving for that. Adjust loads and change the schedule. Back schedule before the bottleneck and forward schedule after the bottleneck. This is one way for doing the scheduling, is you need to do a back schedule before the bottleneck and forward scheduling after the bottleneck. And this is what how we could manage the schedule. Here's another example to show you about where's the bottleneck, and you will see the process 3 is the bottleneck right there because it's processing 4 hours. So this is what we call the theory of constraints. So I identify the constraint, which is process 3. Exploit, make full use of the constraint, which is goes to the buffer, drum and rope. The drum is the piece of the production set by the constraint. The buffer is the inventory established before the constraint, which we need to make sure that we have enough material for the constraints. We don't want that to starving. And then the rope would be the coordinating the release of material when you have. So number 2 is the exploit, make full use of the constraint, and then the subordinate everything to the constraint, so we could adjust everything according to the constraint, which is the rope. And number 4, elevate the constraint. If we could buy another machine or hire more people for that constraint, we could do that to elevate that constraint. Once the constraint is no longer constrained, then we have to find a new one and repeat the process until we find the best time to do. This is the drum buffer rope that we use when we have a constraint, which is basically focused on elevating the constraint using the drum buffer rope technique. And the last thing that I want to mention is which we calculate the work in progress, something related to the constraint, and to find out what the work in progress that you need to reduce it. And we could have the Little's law to reduce to calculate the work in progress, which is the throwboat times the lead time. So for example, in here, if the throwboat is 5 units per minute and the lead time is 5 minutes, we will have 50 units available in the work in progress somewhere in the process. We need to reduce that, and we need to hopefully reach to a 0 work in progress, and we don't want to build inventory in the process. With that said, that's the end of the chapter. Thank you very much, and please let me know if you have any question. Thanks.